Cool. So, good morning, everyone. I'm Harjas, and today I'm going to talk about this self-evaluating lesson content generator. This is a very simple agentic system that simply lets me create any lesson plan, right, for any technical topic. And it has a self-improvement loop in place that takes in any feedback, any failures that my evaluating system generates on the go, and it tries to, fix those and create a full-fledged, perfect kind of learning plan for a beginner. The persona behind this is of a 12th class student who has minimum or no understanding about the technical topic he's here to read about, learn about. And so that's the idea behind this simple agentic system. Now, beginning with how this has been architectured, right? So you simply begin with by inputting your topic that you want to learn. So let's say I want to read about RAG or LLM or MCPs today. I'll just input the topic here. This goes through a predefined prompt which takes in the persona as a system prompt and has a set of instructions, a flow to follow about how the lesson should be generated. After generating the lesson, it is evaluated on a set of 7 rubrics. These rubrics are simply checks like, are all the jargons properly explained, is the entire lesson grounded and it's not hallucinating, and then it also has a check which makes sure that my flow is complete, right? That the entire lesson is making some sense. After this evaluation, if all of these checks pass, it simply ships the lesson and the logs as well to the user. But let's say one of my checks failed, right? It goes in, increases the attempt counter, and this time it again goes back to the generate lesson node. But this time it also has the exact reason of failure, uh, right? Why this lesson came back, and then taking this failure reason again as an input, as a part of a context, it simply creates the lesson plan again, and this cycle keeps on repeating for n number of times, right? Now, all this is again integrated with our global memory, right? Think of this as a very simple JSON file as of now, which basically has topic as the key and then all the failure rules as the values. So let's say my jargon check failed, right, during evaluation. Now what will I do? I will simply craft a rule out of it, right, which this topic generally faces, and then we'll save that in our global memory. So how are these learned rules helping us? So let's say today morning I generate a lesson for LLM, and this time it somehow failed to explain what a foundational model is, right? So in this evaluation check, it will simply craft a rule and simply add it to the memory that, hey, do not use jargons, right? Just like that, and make sure you are explaining what foundational models and other jargons are. Now, next time, let's say in the evening, somebody else comes and uses the system. They also want to learn about LLMs, right? And when they click on generate lesson, this time the context would also have the learned rule which it learned from the mistake it made in the morning, right? And then this time you will get a lesson plan uh, much cleaner in the first attempt itself. So this is how a global topic memory is working, right? Now, let's jump on to how our system is actually working. So we have a simple Gradio interface that takes in the topic name, takes a max retry count, and you simply click on generate lesson button. It will take, I guess, 5-6 seconds to generate it. So I already have the output saved for you, which we can go through while it is generating. As you can see, right, we can see these checks being passed. So accurate, grounded, no unexplained jargons, beginner friendly language, teach by examples, covers key points. And all these are, some checks that we do in a single LLM call. Again, if it passed, it simply ships it as a proper MD file, right? You can either review it over here, or you can even go ahead and download it, right, to view it offline. So This is a very simple, the best execution of this pipeline. Let's go back to our screen and you can see that, it ran perfectly. But, we should also handle some let's some checks or some errors, right? Like let's say my coherent flow or my standalone zero background check failed sometime. How will my app behave that time? So since this is a demo, I have this checkbox also enabled. What this does is simply injects a set of instructions in the prompt that make this system deliberately fail, right? And then that is how I will check my max recount and my rejection logs feature as well. So I have that ticked and I will generate again for this same topic, right? Again, since it is generating, I have the output stored for you. And this is how it looks, right? In the attempt one, you can see that I have few rules that failed. So no unexplained jargons failed, right? It says that the term vector database was introduced and is never defined in the inline glossary. So this is something bad. And then again, standalone zero background also failed. Now, it took these input as a part of context, right? And it went for a generation again. And this time you can see that, all my technical terms were explained and, you know, all the checks passed. So after this passed, it again, uh, shows the rejection logs over here that why we had to do multiple attempt just for users visibility. And you can again, as usual, download your MD file this time and save it somewhere. Let's go back to our original screen where it was running, right? And yeah, we can see that it is working as expected. Now, uh, let's jump on to our global memory stuff, right? So as I told you, we are storing that in a JSON file as of now. We can obviously move it to a better database, a proper database someday, right? But as of now, what it does is that you have the topic name as your key, and then all these rules, right? They are they become a part of the context, and then uh, as these rules grow on, right? You can see that list has grown significantly. As it grows more, what we can do is we can summarize them and we can craft a better set of rules that are not colliding with one another and make perfect sense. This will help us in reducing tokens, and it will also help us in giving a better context to our LLM when it is generating any lesson. So this rule conciliation is also an important feature that can be added sometime later. It's not added currently since it's a very basic presentation, and the core goal of this project was to just showcase how to build a simple agentic system, agentic workflow that helps us to create a lesson plan. Right now, let's talk about the technical stack used. Okay, so it has been using LangGraph as the agentic framework. So we have it's again, we have used sequential nodes as well as we have used conditional nodes over here to make decisions whether to go back to the generate lesson or to ship and simply export it. And a proper state graph is maintained which keeps a track of all the retries, topics, memories, etc. That's one thing. Coming to our LLM model selection, I am using Gemini 2.5 Flash for this. Model choice again, I did not have much time for evaluating models, so simply chose this. But obviously, we can set up a proper evaluation pipeline for our model selection as well, and we can go for a better model uh, if required. Mm, so yeah, this is pretty much about our pipeline. You can find the entire code base in my GitHub repo, right? And it goes by the name content system, and my GitHub ID is harjasdt. So yeah, you can check out the entire code base and just to to get this running, just clone this repo and just add the Gemini APK, the Google API key to your environment file. We have a sample environment maintained over here, so you can just uh, you know add these things and change the model if you would like, and then that's all. You can try this out in a local space as well. Thank you.